Parallelograms.
What?
The first of many quadrilaterals we're going to talk about. That's a parallelogram. This one happens to be yellow for no particular reason. What, Tommy, is a parallelogram? I'll get you started.
Parallelogram is a quadrilateral with two sets of parallel lines.
How's that sound? Good? I got one good. We're going with it if it's okay.
Yeah, great.
All right, great.
It's pretty good.
Okay, good. Two pairs of parallel sides, opposite sides parallel, however you want to phrase that. That's the definition of a parallelogram. Everything we do from this point on becomes a property of a parallelogram. You will need to be able to make the distinction. Opposite sides parallel, because it's a parallelogram. Everything else is a property of a parallelogram. So Tommy, what else do you think might be true about that yellow thing?
The opposite parallel sides are equal.
Okay. I'm not going to confirm nor deny that at this point in time. What else?
As the two sets of angles are equal. Two sets of
Could you be more specific?
The opposite angle, angle opposite, like across from it is equal.
Okay. What else you got? Well, those are parallel lines, right?
They have the same slope.
Correct. What else? What?
That was not me.
Okay. You have Tourette's, you're just shouting out. You like math Tourette's, you just shout out random math facts.
Oh my god,
What did you shout out in that one?
I said channel double bottom.
Oh, that was your 8th grade nice team.
And 7th grade.
Yeah, like, no, he wasn't.
Yes, you were.
That was the full name of your teacher.
Yeah,
No,
only 8 people in our
channel
class.
I would question your arguing skills there.
He would hit kids with a frying pan.
He was horrible. No, he wasn't. Yes, he was. And your final response was, Are you on debate? That was solid.
My brother.
She gave up. That was the best part.
No,
You
I
won the
said
argument at that
he
point.
hit-
Natalie, you probably think he was horrible because he kicked you out in 7th grade.
At least he
Oh.
didn't yell at me in front of the whole class.
Yeah, he didn't yell at me either.
He
He
didn't
doesn't
yell
He
at
didn't
me.
yell at me. He just said, what did he didn't
He
yell at me.
used the frying pan more than he did me.
What? Wait.
This video is the most frightening business man. That's the way we'll start.
But he did.
Ask
He
Tommy.
has the
Tommy,
biggest
did he hit you with a
head.
frying pan?
No, but he yelled at you like every week.
Nice answer, Swami.
Maybe, but you know, he wasn't
Tommy the same.
It was my fault.
Good argument.
Tommy, what else?
He just has him in his cap.
That's it? You're done?
Yes.
Baby. What do you got here?
The sum of the exterior angles equals 360.
Oh, you tapping into yesterday's lesson. Awesome. Is that dependent on it being a parallelogram?
No, that's
No,
just
but it's
dependent-
true. Yeah, yeah. Anything else? Before I just start clicking away and you write like mad people? Okay, here we go. Opposite sides are congruent. Well done, Tommy. Notice that's an if-then statement. Ooh, if it's an if-then statement, maybe we could reverse that.
it. Jinx, nobody said that.
Opposite angles are congruent. You think we planned that ahead of time, Tommy? And then you quit on me. And you let frickin' frack it into an argument. I'm blaming you for that, Tommy. If you would have stayed true to the parallelogram, that transaction never would have happened.
Am I frick or frack?
Which would you prefer to be?
I think frick.
Frick? Frick it is.
This is great.
Frick, frack.
Okay, what's that?
Just
make that up right now.
No. No, yes.
Now you do, you've learned something. Other than the properties of a parallelogram.
Did you see that? I just
Someone
saw
just
it.
fell
Yeah,
off the roof.
I saw that.
Oh, that wasn't one of the custodians. Yeah, that's ruined my holiday season.
I was like, was that
This
a
one
spider?
actually falls. Someone
I
jumped
jumped
Yeah,
out
it
of
sounded
it
like-
for my life.
It was
That's
probably
what happens when you eat too much math.
Oh, it might,
Did someone jump off?
it might just be like the snow that fell.
Yeah. People equals
Someone
snow.
jumped off the roof. Watch it, you really want to say that you jumped off the roof?
Snow is people time. You gotta believe.
Someone actually jumped off.
Snow is
Yeah,
people.
somebody actually jumped off the roof and we're just sitting here quietly ignoring
Ignoring it. Didn't we also acknowledge it though?
it. Consecutive angles are supplementary. Tommy, I was hoping you'd get this, because you got parallel sides, and one of the other sides would be a transversal, and therefore you would have consecutive interior angles, which would be supplementary. What does the word consecutive mean, Grace?
Consecutive angles? Wait, what?
No, the word consecutive, what does it mean?
Oh, consecutive, like, I don't know how to explain it, sorry.
In order, correct.
Oh, okay.
Thank you.
That's what I was trying to say with my arm.
I understand. That sounds good.
I bet the people who are watching this video too is
Anything to say to that?
trying to do it like.
The diagonals bisect each other. Joanna, what's a diagonal?
A line or a segment
A segment, I like that better, yeah.
that, I don't know, cuts through something else diagonally. I don't know what a diagonal is, I can't explain that.
See those green things?
Yeah,
Those are diagonals.
well, yeah, I know, but I don't know how to explain that in, I don't know how to verbally explain it.
I understand. In a parallelogram, that's perfect. However, when we start looking at larger polygons, we'll have more than one opposite thing. So for a parallelogram, it's a perfect description. It's a segment that connects the opposite vertices. Matt wants to add to that, though.
It just, wait, no, never mind, because that'd be saying the same. I was gonna say.
You'd be repeating yourself? You'd be saying the same thing over and over again? You'd be redundant? I understand. Okay, we'll go with it. For now, that'll work just fine. We'll tweak that diagonal definition later. What does it mean to bisect? Huh? Yeah.
For something to be in two equal parts.
Yeah. AKA cut it in half. It does not say the diagonals are the same length. Notice the tick marks in there. It just says they cut each other in half. So what would be special about that point of intersection of the green segments? I'm hesitant to call on you now, Tom. You did me wrong the first time. I'm not calling it. I'm ignoring you. No, I don't see you. Or no, I don't see you. Yeah, Joanna.
Wait, can you repeat it?
What is special about the point of intersection between the diagonals?
The midpoint of each diagonal.
Good, it's the midpoint of each of those diagonals. All right. Solve for angle D, as in donkey. Bust out those calculators, kids. We don't want any math errors.
That is what it is.
Oh, that question. What do you want?
I know the answer.
Congratulations. Let's give it up for Tom, everybody. Good job, buddy.
Thanks.
Is that D in the top right?
No, that's B as in badger. G is in the bottom. Don't. Can you not see that? Can you not see that? Give that
I thought
eyes.
that was you, yeah.
We're gonna move on. You can't see.
It's all your seat.
Shh. Think about it. What?
Can I answer it?
No. What? Wait, you raised your hand, and when I called on you, you told me I'm raising my hand.
Machik, you're smart.
Let's give it up for Machik, everybody. I realized he was raising his hand. Good job. So proud of you. Sarah, what'd you get for X?
I got 27.
Hold on, let me check with the masses. Everybody?
Yes.
They like that answer. Oh, Sarah, what did you get for angle D?
81.
Hold on 1 second. Everybody else?
Yeah.
They like that answer. Anybody not get 27 and 81? Do we need to go through it? Speak now or forever hold your peace. Beautiful. Is that what you got, hand raiser? Good boy, good job. 81. You're welcome. Alrighty. I got some coordinates for you. Is that a parallelogram? At this point in time, the only thing that we have that's...
Oh,
You have a question?
no, no, no.
Okay. The only thing that we have to check whether or not that's a parallelogram is the definition, because the definition is the only thing that we've done that's reversible. Because remember, all good definitions are reversible. So if a parallelogram, if a quadrilateral is a parallelogram, then it has opposite sides parallel, and if a quadrilateral has opposite sides parallel, then it is a parallelogram. So how would we check to see if RSTV is a parallelogram, Kira?
Distance formula to see if the sides are equal.
Nope,
Not distance
not
formula.
yet. Not distance formula. Simon,
We have to check the slope.
slopes. Do it. Calculate the slopes. You might want to do a sketch. The reason I would say do a sketch is because you don't want to accidentally calculate a diagonal instead of a side. I.e., if you look at RSTV, can you easily tell which sides are opposite? You might not be able to, and therefore a sketch will assist in that matter. This will be good slope practice for you. Question?
What ones do we put in like slope?
What do you mean? Like, what are you looking for the slope up? Okay, so then put in S into. It's like Inception. That's pretty nice. You can put like change and fruit roll-ups. I don't think a fruit roll, but maybe one of those flat ones. It's not a roll, flat out. Like if you flatten out your fruit roll, well, it would be a fruit roll. It would be a fruit flat. You put fruit flats in there. You put a
tea bag.
Yeah.
tea bag, car keys.
It's the sides.
Tom wants a fruit flat.
10. Well, let's see.
Double hood dollars for fruit flat.
Fits like a champ. You got a 20? Let's put a 20 in there.
One Machik is low
He has
key
money.
getting
Look,
money.
everybody got it.
Ooh, 20 and 5. Let's see if they fit.
I wonder if we'll fit.
Mr. He just leaves with the money, he never comes back.
Yeah, we should close it, never open
You
it
should
again.
take it
until
and-
like lunch.
Oh my eyes.
I'm having trouble.
Not sure.
Oh, wait, there's another
You got another 20? See how much you're holding.
What?
Now put the calculator in and make sure it works. Oh, it's got a safety strap too, so the calculator.
It's like a
In
seat
case things get heated while you're doing some calculations. And it's got a carrying strap.
Oh, yeah.
Whoa, man, advance. This is the future.
One of the coolest things I've ever
Now,
seen.
now it's a lethal weapon.
I'll say the lethal weapon.
If you hit someone with a calculator, they're gonna die.
No, they're not.
I mean, yeah, you're right, I guess.
That ended was the concussion, but not.
Silver.
Well, like for like 30 minutes, maybe, like straight.
Oh my god.
I mean, why would you do that?
Emily,
I don't know.
what is the
Correct
slope
case?
of RS?
5 halves.
Can somebody confirm 5 halves?
Yes.
Awesome. So, Emily, what side is opposite RS in our parallelogram?
TV.
Television. What's the slope of TV?
I got negative.
Uh-oh. Negative 5 halves?
I got
They got 5 halves. So now we know that RS is parallel to TB. Brandy, what are the other two sides?
RT has a slope of 1 and SV has a slope of -1, so they are not parallel.
RT and SV are not sides, though.
Never mind then.
Those are diagonals.
No, they're like the.
Let's review.
No, they're like.
Thought this might happen. I'm glad it did. Thank you, Franny. You played right into my hands.
We'll keep it.
That's great.
Monty, could you give us money? Yeah.
How do you name a polygon? Well, there's my sketch of a parallelogram. You can start at any point you want. I'll start here. And you can start with any letter you want. I'll start with T. Now you just need to go in order around the figure. You can't jump around. Jump up, and get down. B, R, and S. So that it goes in order around. Okay. You could go the other way if you... Whoa. Let me fix my parallelogram here. You could go the other way around and do V, R, and S, but when you're done, it has to go in order, RSTV, around the shape. Okay, and that's why I suggested you sketch. We did this one already. What'd you say, Emily, 5 halves? 5 halves. Which means they're parallel. So far, we're halfway done. And what's the slope of ST, Herman?
Slope of ST?
ST. Salamander turtle.
I don't. Wait, slope of ST. I don't know. Find it. Hold on.
Weren't you supposed to be finding it?
Yeah, I mean, I found the first one, and then we started talking, and just got distracted.
2/5.
2/5? Somebody else?
Yes.
Yeah.
2/5. What'd you find for this guy? VR.
2/5.
Beautiful. So therefore, it is in fact a parallelogram. You could have graphed it if you wanted to, but that's not going to get you anywhere. So, yes?
Do you need to find the distance of the sides or no?
Not yet. Later. Because the only way we know to prove it's parallelogram is talk about the parallel sides.
Okay.
Because those other things we did were if-then statements, which means they're not reversible. Oh, there's a graph. Yeah, we don't need it. Diagonals. They bisect each other. One diagonal divides a parallelogram into 2 congruent triangles. Let's go back a little bit. Doink, 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 doink. Why does it keep popping back? There, no, that one, one more. That one. If I take one of those diagonals, this guy, it splits the parallelogram into 2 congruent triangles. Why? No, we've heard enough out of you today. Trisha, why are those 2 triangles congruent? Here, you know what? Let's not use that one. Let's make your life a little bit easier. We'll come over here. Let's use this one. Why is triangle ABD congruent to triangle CDB?
Well, angle A and angle C are equal.
It's a good start. Whoopsh, whoopsh. Property of a parallelogram says the opposite side. Opposite angles are congruent. I like it so far. Say again.
The
Diagonal.
diagonal is equal to itself.
Good. Reflexive property. So far, so good. I got an angle and a side.
And then since they're parallel, are they equal? So A and B.
I kind of like that. What don't I like about that?
Side, side.
Right. And what do we know about
That doesn't work.
that doesn't work? So what else you got for me?
So you need to do DA is equal to BC.
Ooh, I like that. Good.
And then it's side equals side, which works.
Or
Or side angle. Or no, just kidding. Or side angle side.
yeah, you told me that already.
So okay, well, so you have side angle side, and then you have side side side.
Beautiful. 2 reasons why that works. Now, if I change colors, oh, I don't know, red, and I come across this way, she could repeat the whole process again. Probably side, side, side would be easiest to prove the 2 triangles are congruent. Now that I got both diagonals in there, let me clear out all that gunk and start over. Put both diagonals, let's call that center point X. What can you tell me about all those little triangles? Yeah.
I have a question about before.
Certainly.
How could it be side, side, side? Because I thought they all had to be like in a row.
They were. She just threw in an extra angle just to make things interesting.
Oh, okay.
Matt,
Oh, are they all congruent?
they are not. Maciek,
The vertical angles are congruent.
that's correct. So? That is Tom, very good. Hey everybody, Maciek knows Tom, let's give it up. Do you know everybody else's name? I guess not.
The name text.
Yeah. Which way? What?
I was gonna add like
What were you gonna add?
I know another thing.
I know another thing. He knows another thing.
Good.
Okay, well,
You're just going, right? I didn't even say go ahead. You're just
Oh.
gonna continue with what is that other thing you know?
alright. Okay, so A, X, and XC are equal and DX.
Why?
Because it's the midpoint.
I don't like pronouns.
Because X is the midpoint.
Of.
AC and DB.
Therefore.
Therefore, DX and XB are congruent.
Okay.
And AB and DC are congruent because it's a parallelogram.
Okay.
And AD and BC are congruent.
Okay.
So now we can do side, side, side.
For what?
For the AXD and triangle AXD and triangle BXC are congruent.
And
And triangle ABX and DXC are congruent.
are they all congruent to each other?
No.
No, we have 2 pairs of congruent triangles. So one diagonal splits it into 2 congruent triangles. 2 diagonals split it into 2 pairs of smaller congruent triangles. Outstanding. Okay. Solve for RS and T. Turner, what'd you get for R?
I got R equals 18 over 4.
Which is
4.5.
also 9 halves.
Yeah.
Everybody else?
Yeah.
Good. Matt, what'd you get for S?
I got 3.
Why?
Because 7s plus 3 equals 8s. So you set them equal, and then you solve to get s equals 3.
3?
Yup.
Yeah.
Good. And Alex, what'd you get for T?
20.
Why?
Because Z, W, and Y is alternate interior angles with W, Y, and X.
Nicely done. Okay, everybody see that? These two are alternate interior angles because these are parallel. There's my transversal, AIA, makes those two congruent, so therefore T equals 20, right?
Yeah.
Yes.
Beautiful. How big is angle WXY? Natalie?
58 degrees.
Nope. Tommy?
122 degrees.
Why?
Because 18 plus 4 equals 50, and then WXY is substituted to that.
Good. How big is angle WZY? Tommy?
122.
Good. How about ZWX? You said.
58.
Good. Let's see. What else do we know? Okay, that's 20. Let's stop there. Let's see what else we got. All right, find X and Y in that guy. There's some pretty colors in there for you. If you're stumped up, excuse me, special time in my life. If you're stumped, I'll give you a hint. Alex could probably help you with this problem. Oh, that's a good hint. Don't look at me like that. Caroline, what'd you get for X and Y?
I'm not finished yet, but I got y equals 13.
Y equals 13?
Yup.
Okay, there's a couple different ways to do it. Could you tell me how you did it?
So I knew that angle EYF is alternate interior angle to YED. So I knew that angle YED is 45.
Uh-huh.
And then I added 70 and 45 together to get 115. And I subtracted that from 180. And that was 65.
I'm just gonna set it up a little bit differently, if that's okay.
Yeah, that's fine.
Just because we're less likely to confuse people if we do this. But that's what you're talking about, right?
Yeah.
Yeah, so should I use the top triangle, did the triangle sum, got that. Okay, that's one way to find y. Another way to find y is to realize that that whole angle is 115. And what's the relationship between this angle and this angle in a parallelogram? Natalie?
They're supplementary.
They're supplementary. So you could do, which is exactly the same thing we'd get set up here because 45 plus 70 is 115. Okay, did you get X?
Yeah, I got 10.
How?
Using the same method, so angle FEY would be 70 degrees. And then you'd set that all equal to 180.
Beautiful. Add it all up, set it equal to 1. Question in the back?
I did it.
Is not a good way to start a question.
Hi.
Hi.
I did it.
That's not really a good way to start a question either.
Okay, so I did it.
Wait. Just start with a question.
Just say your question.
I did it.
Statement.
That's a
Start with the
statement.
question.
I'm getting to the question.
Say the question, not the statement.
Well, I did a little differently. Like, would this still work? No, I'm good. Okay. I did 45 plus 70 times 2, and then I divided that, or I subtracted that from 360, and then divided that by 2, and I got like 130 or whatever, and I divided that by 2, and I got 65. So I knew the two angles had to be 65, so I just set them both equal to 65.
Where'd you do that?
I did too.
That's what your roundabout way of getting the same
It's
answer.
America though. I saw it right on.
Yeah.
That works.
Nice.
I mean, it's not the most efficient method in the world, but it still works. I mean, they still make push lawnmowers.
Yeah.
Somebody have their hand up, or are you just waving your hands in the air? Okay, I saw somebody doing aerobics over here. All done.
Wait, what's the joke?
Robot that walks around like vacuums your house.
Yeah, I'm getting it. I'm getting a Roomba lost. I'd be serious.
I have to explain the joke to you.
I don't get it.
I don't get it. It's a